can start anytime.
Okay, I got to shush. Hi, in today's lesson we're going to look at angles of elevation and depression. What are they and how we use them in our trig calculations. An angle of elevation. We often see this when we come across trig problems, but what is an angle of elevation? Well, an angle of elevation is the angle that's measured from a horizontal looking upwards. Let me show you what that means. We have a horizontal line here, and let's say I'm standing on the ground. If I look up, let's say that there's a kite flying in the sky, and I look up at that kite, the line that I look up is called the line of sight. The angle of elevation is an angle that's measured from the horizontal ground up to my line of sight. Think of it as elevation, elevate, going up. So the angle of elevation is from the horizontal up to the line of sight. Then we have the angle of depression. Well, the angle of depression is the angle that's measured from the horizontal looking downwards. This one's slightly different. Let's say that we have a building and we'll say that one of my friends is down on the ground and they're looking up at me at the building. And let's say that there's a rooftop bar on top of this building and I see them down below. So the angle of depression is the angle that I'm looking at them from the horizontal going down. My line of sight is from the top of the building looking down to them. So we say the angle of depression is from the horizontal down to my line of sight. Think about it as depression down, DD. So just to recap, angle of elevation, horizontal up, angle of depression, horizontal down. Okay, once we know what they are, let's see if we can put them into practice. Why don't we do an example of each, and we'll start with an angle of elevation. Example 1, an angle of elevation. Let's say a captain on a ship sees a lighthouse in the distance. He estimates that the angle of elevation to the top of that lighthouse is 10 degrees. And he is roughly, let's say, 680 metres away from that lighthouse. What that captain wants to find is, how tall is the lighthouse? Okay, first thing we need to do, let's draw a right angle triangle amongst the picture we drew. So we have our ship, we have our lighthouse, we know the distance from the ship to the lighthouse is 680 metres, and we were told that the angle of elevation is 10 degrees. So remember, the angle of elevation is from the horizontal up, we'll label that as 10 degrees. I don't know the height of the lighthouse, that's what I'm trying to find, so we'll call that X. Once again, we have a right angle triangle and we have to label our sides in relation to my 10 degree angle. So once I label the opposite and the adjacent, I recognise the tan ratio. So let's go all the way back to lesson 2. Tan 10 is equal to X over 680. And because my unknown is on top, all I have to do is multiply both sides by 680. So I'm going to end up with an equation X equals 680 times tan 10. I punch it in the calculator and I'll get a value of 119.9 metres, but I want to round that. So I'm going to round it to the nearest metre, which works out to be 120 metres. Basically, my ship is 680 metres from the lighthouse. I'm looking up to the top of the lighthouse at a 10 degree angle, and now I know that that lighthouse is 120 metres. Example 2, angle of depression. Let's have a look at this example. The angle of depression from the top of a lookout to a house is 40 degrees. The lookout is 460 metres vertically above the level of the house. We want to find the horizontal distance from the house to the lookout. Now, whilst this sounds a little bit confusing, it's really easy if we draw a picture that involves a right angle triangle. So I'm going to draw my lookout, I'm going to draw a house. I have the horizontal distance from my house to the lookout, which is what I don't know. I'm going to call that X, but I know the height of my lookout was 460 metres. What the question did tell me was that my angle of depression from the lookout to the house was 40 degrees. Now remember, the angle of depression is from the horizontal down to my line of sight. So this is where my angle of depression is. Now, you might notice from example 1, the angle of depression is actually the same numerical value as the angle of elevation. And that's because my horizontals are parallel lines and they create alternate angles. So although I'm finding the angle of depression, I'm really finding the angle of elevation. It's just that graphically they're in different places on my picture. So I've got a right angle triangle, I've got the opposite and I've got the adjacent. You may notice a lot of real life applications are tan, and that tends to be the case. So once again, tan of 40 is equal to 460 over x. My unknown is in the denominator, so if we remember, when my unknown's in the denominator, I swap them around. So I'm going to have the equation x equals 460 over tan 40. If I punch that in my calculator, I get a value of 548.20, and once again, I'm going to round it to one decimal place this time, just to be a little bit more accurate. So my final answer is 548.2 metres. That means the horizontal distance from the house to the lookout is about 548.2 metres. I hope this has helped you understand the angle of elevation and depression. I do have a few further examples, so if you'd like to subscribe or like, you've got access to more examples, and we'll give you a worksheet with plenty of answers and solutions. Cut.